The history of China's energy storage industry is intricately tied to its ambitious renewable energy target and innovation drive.
As of the first half of this year, among the companies from mainland China with a market value exceeding 1 trillion yuan, only 2 have their headquarters tucked away in third-tier cities. One is Kwaichow Moutai and the other is CATL. When CATL was established in 2011, no one expected that a company from a small place could defeat big Japanese and South Korean corporations, quickly become a giant and dominate the global power battery industry for 6 consecutive years. Today, for every 100 electric vehicles produced in the world, over 35 are equipped with batteries from CATL. How did they achieve such tremendous success? At the beginning of this year, we visited the CATL factory and interviewed more than a dozen engineers and suppliers. In this video, we will take you deep inside CATL to uncover the manufacturing secrets of this trillion-yuan giant by looking at their technology, processes, and employees in detail. Near the headquarters of CATL is the factory where the batteries are produced. This facility filters the air 25 times per hour, maintaining a level of cleanliness comparable to that of a cardiac surgery operating room. The entire production line is approximately 1,500 meters long, and it takes about 15 days and over 20 major processes for a pile of raw materials to be turned into a single automotive power battery. A power battery contains hundreds of cells, each made up of various material components that form electrode sheets. Each cell must have highly consistent physicochemical parameters from the inside out. Otherwise, if even one cell is faulty, it is difficult to guarantee the performance and safety of the entire battery. Last year, CATL produced 190 gigawatt-hours of power batteries, which is equivalent to 200 million individual cells. The defect rate they demand in the market is 1 in a billion, meaning that only one faulty cell is permitted out of 10 million vehicles. In summary, power battery manufacturing has 3 characteristics: long processes, high demands, and large scale. The biggest competitive strength in this industry is manufacturing capability. The secret to CATL's success lies in its ability to produce better batteries at a lower cost while maintaining a massive scale of production. It sounds simple, right? Just making a battery, how hard can it be? However, power battery production is the primary sector that involves complex materials and numerous processes, and there are over 20 major operations in actual production, which exponentially increases the complexity of battery manufacturing. We can understand this complexity as a high school mathematics problem. Suppose in the battery manufacturing process, the success rate or qualification rate for each process is 99%. Then, multiplying the rates of 20 processes would result in an overall yield of only 81.7%. If the rate of each process decreases by just 1 percentage point, the overall yield plummets to 66.7%. For cylindrical batteries, the yield rate can typically be 87% to 89%, while CATL achieves 94%. This means for producing the same number of batteries, CATL's direct material costs are about 5% lower than those of its competitors. Reaching a 94% yield rate is extremely challenging. It doesn't mean that CATL is doing just a few things well, but that it performs strongly in all areas compared to its competitors. Let's look at the specific manufacturing process. One of the early key steps is the slurry mixing, which involves homogeneously mixing the positive and negative electrode materials, and then applying them onto copper foil or aluminum foil. At this stage, the foil is moved forward by rollers. In pursuit of higher energy density, CATL uses thinner copper foils than the industry standard and has achieved faster production speeds. The thinner the copper foil, the higher the theoretical energy density of the battery. However, if the copper foil is made too thin, it's prone to wrinkling during production. CATL has managed to make copper foil that is only 4.5 micrometers thick, less than 1/10 the diameter of a human hair, while still operating the machinery at high speeds without losing production rhythm. This is one of the most challenging aspects of battery manufacturing. seeking balance under extreme conditions to complete the coating process. The sections on both sides of the electrode sheet coated with positive and negative electrode materials are cut into a serrated shape, forming protruding ears called tab. After tab formation, the sheets undergo a winding process, leading to the step with the lowest yield rate in the process, tab welding. This involves welding together the dozens of thin tabs protruding from each cell. The challenge here is precisely controlling the output energy of the laser welding equipment. If the energy is too high, the tabs can easily deform or gas holes can form between them. If the energy is too low, there could be poor or missing welds. Both issues can lead to short-circuiting in the battery. The yield rate of tab welding in some factories can reach 94%, but CATL has achieved a rate of 97%, which is exceptionally high. CATL has continuously sought optimum solutions under such restrictive conditions, and now it can achieve a yield rate of over 99% for most of its processes. For instance, in the winding industry, where the average may only reach 97%, CATL excels with a 99.8% yield rate. Yet, this is not enough for CATL as they push their pursuit of yield rates to 4 decimal places. They found that during the welding of the battery's top cover, controlling the distance from the fixture to the welding point to around a couple of millimeters resulted in a higher yield rate for the batteries. Another battery company, aware of this parameter, and after using CATL's settings for a month, found that their battery yield rate indeed increased by 0.02%. In 2022, CATL reported an operating revenue of 328.6 billion yuan and a net profit of 30.7 billion yuan. Let's do a rough calculation. Improving the yield rate by just 0.01% would mean an increase in revenue of 30 million yuan. Every 1% increase corresponds to an income of about 3 billion yuan and 300 million yuan in net profit. As the industry leader, CATL has more capacity and willingness to refine every detail of its manufacturing process than other companies. But CATL's secret lies not just in mass-producing batteries, but also in mass-producing factories. CATL currently has more than 30 production bases and hundreds of production lines. Their system for optimizing production efficiency mainly consists of 3 parts. First is the capacity for materials and equipment, R&D. Within CATL's engineering and manufacturing system, there is an equipment development division that develops equipment prototypes and modifies equipment. Last year, CATL encountered a production issue. The injector left residual electrolyte in the tube after injecting it, which could leak onto the cell surface. An engineer came up with a solution to add a reverse thread in the last second of injection, which would hold the electrolyte instead of allowing it to leak. Because CATL can develop and adjust its own equipment without waiting for suppliers, they can solve related problems faster. The second part is the smart manufacturing system. CATL's current smart manufacturing system, comprised of over 100 automated machines on the production line and more than 6,800 data collection points, can manage people, equipment, materials, environment, and process parameters during production to identify and intervene in line issues more swiftly. This system is complemented by a high-frequency horizontal expansion production mechanism. Simply put, CATL requires engineers from various bases, especially from process and equipment departments, to write a weekly production line improvement plan, which enters performance assessment. The head office selects valuable improvement plans to establish new standard operating procedures, SOPs, and expands them horizontally across all production lines. The improved injector mechanism mentioned earlier was synchronized to over 500 injectors across more than 30 CATL production bases within 2 weeks through this horizontal mechanism. Just for the winding process, CATL implemented over 200 horizontal expansions last year, while another second-tier manufacturer did it around 60 times. Through these mechanisms, CATL can replicate and optimize production lines across new factories more rapidly. KTL's Z-Base managed to transport equipment into the factory and reach the target yield rate in just 45 days, while a typical battery production line may need 6 to 9 months. Here, not only are batteries considered products, but the factories themselves and even the employees are viewed as products that can be replicated and optimized. CATL, with a workforce exceeding 110,000, employs over 80,000 blue-collar workers and more than 10,000 technicians and engineers. How can such a vast number of people operate with the precision and efficiency of a machine? This relies first on detailed and sometimes even tedious standard operating procedures, SOPs. Even for a simple process like drying, CATL has more than 70 different SOPs. An engineer told us about a question that was very confusing when they first joined CATL. How does CATL ensure that over 80,000 employees do not wear their clean room shoes outside? CATL monitors this by installing many cameras at the entrances of clean rooms and having specialized guards. A verbal warning is issued the first time an employee wears the shoes outside, followed by a written warning for the second infraction. Multiple warnings can affect an employee's promotion. In addition, CATL has a comprehensive training and examination system to encourage continuous learning among its employees. New engineers must spend 3 months on the production line, familiarizing themselves with each process and completing 50 specified tasks before they can be officially employed. Once regularized, they have KPIs for taking classes, with an average of 1 test per month, and these courses are prepared by engineers who are level 9 or above. For these more senior engineers, one's contribution to the courses also impacts their promotion prospects. In 1999, Charlie Munger said something at a shareholders' meeting that perhaps could summarize CATL's success today. He believed that process innovation contributes more to modern manufacturing than technological progress. Elon Musk, founder of CATL's largest customer Tesla, has expressed similar views. And this type of success is not without precedent. CATL somewhat resembles TSMC in that it earns the most profit within the industry and uses it to continuously improve research and development, R&D, as well as manufacturing, thus earning even more money. It becomes increasingly difficult for other companies to catch up. Now, the most advanced chips can only be produced by TSMC, of course, under one condition, that for a long time, the demand for chips has been increasing, doubling even. Whether CATL can become the next TSMC also depends on to what extent our demand for batteries will grow. Of course, success does not belong solely to this company. CATL is actually representative of the overall rise of China's power battery industry. It is a combination of consistent policy drivers, corporate investment, and the relentless efforts of engineers that has given birth to this industry with an overwhelming advantage globally. And these dominant Chinese companies will not rest on their laurels. In the power battery industry, which is one of the few that is still aggressively expanding today, they all have their eyes on CATL's position. This is yet another brutal and exciting story.